Hello, my name is Carlos, and I'm going to explain you here my entry for the module Machine Learning for Creative Practice at Goldsmiths, University of London. So I made a very simple game where you need to punch boxes using a leap motion, following the beat of the music. So let me show you how the game looks like. Firstly, we'll be able to see our hands thanks to leap motion here, and we see that boxes are spawning from the bottom of the screen down to the top, very similar to many rhythm games. So what we need to do is just punch a box. So every time we successfully punch a box, we'll see explosion. Every time we punch a box, we get around 12 points, and the logic is very simple. We just need to keep punching. Let me show you what happens when I play a little bit further. As you can see, the gameplay gets harder and also the background reacts dynamically. So for doing all of this, I'm using the Rapid Leap plugin, which is a plugin being developed here at the Goldsmiths. As you can see, if I don't move like a punch, I don't make this kind of movement, the boxes will not react like that. This is because I'm using several features for the punch, but also if I don't punch the way I intended to, it will misclassify the gesture. So for example here, if I make that movement, it's a very slow punch. The network is not trained for this, so it will not understand. So I think you get an idea how the game works. Let me show you how all the tools looks like and how the editor looks. I will just minimize the screen, and then you can see here the game editor. This is the main menu scene where the game manager is, and I have all my classes for handling the logic, audio, levels, audio. You can also configure the audio in game. But let's jump to the machine learning bit. So inside level 1, you can find here under the scenes folder, bit puncher. Level 1 is where it's having all the components regarding the machine learning processing. So inside the object.yml components, you can find both classifiers for the left hand and the right hand. And I will quickly introduce the tool I'm using. So this is Rapid Leap, as I told you before. This is a tool that I'm helping develop. It allows to perform 3 types of learning: classification, regression, and dynamic time warping. I'm using classification to classify the punches, and you can configure what you want as an input. I'm using right now a dummy object, which is located in the center of the palm of the hand. So actually right now it doesn't matter if you have your fingers open or closed, because what matters is the features that I extract from this dummy object in the palm of the hand. Here I have also my training examples, which I can open, I can explore, I can modify if I want to retrain my network. And here is the features section where I can choose how many features I want. Right now I have 3 features: rotation, acceleration, and velocity from this dummy object. But I could say that I want less for some reason. I only want 2. So I will work with rotations and acceleration. Or I want more, so I can go with rotations, acceleration, velocity, and position. And I can also modify what features I want inside the code and say like, well, I want something else. Maybe I want the relative distance between both hands. So I can create a new feature extractor inside the Rapid Leap class. But what I found it worked best for me was having these three features: rotation, acceleration, and velocity per hand. Nonetheless, developing my own tools instead of using the Wakinator proved to be a great challenge and really time consuming, because Wakinator does a lot of things for you that work really well, like serializing the data. Well, Unity serialization system doesn't work really well. So all these training examples, I just couldn't serialize into one file using JSON, the JSON built-in Unity serializer. So instead, I will show you what I did. In the project folder inside assets, I created the subfolder called rapid tip data. And here, you can find all the JSONs. So for the model, it was really straightforward. No problem with that because the rapid lib API was already taking care of that. But for the training data set for both hands, I needed to create a folder and serialize each of the feature vectors independently. And this was a real pain to work with and actually really slowed me down while developing the game. And not only that, it's really prone to errors, probably because the way I'm handling all the data. So unfortunately, I think this has proven to be a great problem for me. But of course, there are several solutions right now for this. I could, instead of serializing using JSON, I could use binary serialization, or I could try and find a more standard C# JSON serializer to serialize everything into one big file that I believe should be doable, but not in the time I had to develop this. Also, there are more things that you could do with the hands. Probably I could classify more kinds of punches: punch up, punch down, punch left. But as I told you, and you can see, computing all this data right now, it's a really slow process. So I didn't have time for basically doing more. But well, this is all. I hope you enjoyed. And please, any questions, let me know. Thank you.